Yo, yo, yo. Is this thing on? Hello? Hello? Hello, hello? What up, chat? If that's your real name. How is everyone doing today? Good, I hope. I get some code running. Mr. Beast! Wow. There he is. I always thought he was just a myth. Alright, I got a screen on the thing. On the breadboard. So I think you can say things to it. I think that is a possibility now. Try it out. What was the command for it? Something display, right? Or OLED, right? Oops. Yeah, there we go. I think we gotta do a lid connect before we can do a lid print, but we'll try it. I guess that does not count as a command. Do I not have it in here? Nah, it's in here. Why didn't I like that? Is the regex not picking up, yeah, that's probably what it is. Oops. Oh geez, how is this regex working again? That's capturing all of these. I guess I could just do it, I mean, that would be the easiest way. I can change it later. What? Access denied constants. Okay. I can maybe make a short circuit in here. Or like certain commands. Let's see where we're calling our test param. They're right here. My awful Python code. I'll start messing with this calculator here in a minute. I found some PDFs. The person uploaded to was it the Internet Archive? A component catalog from Matsushita, i.e. Panasonic, before they were Panasonic. Pretty badass looking document, which has basically all their parts in it at the time. This is 2 years after this calculator that I'm looking at was made, but I feel like the components are probably going to be similar enough that it's not going to really matter. So what I've done is I've pulled out the relevant pages. I've printed those out. I also have a smaller PDF of them. Oops. There we go. And that also gives me the pinout for their T24 or TO92 package, which is nice. So it helps if I show you guys what's going on, right? Yeah, so cool PDF. Got all their parts listed for 1974. So I can use this to look up some stuff, which is pretty neat. They also have like compatible parts, which is pretty neat. They have recommended or example circuits on how to use some of these parts. Honestly, pretty cool PDF. I was very interested in like the variety of CRTs, like gray tubes that they have. Like looking at some of the odd shapes on these. Like look at that one, this one. These are probably for like oscilloscopes or something. This one's really weird. I thought this one was super fun. And they got dimensions and measurements. Pretty cool document. fun. Not behaving at all. No, I don't have debug logging on. Hello? Here we go. Oh, hello there. Don't mind me, I'm just spamming my own chat. Weird. That's the old one. How are you doing, LSWSE Science? Oh man, I put that on the wrong one. Duh. Yeah, right. I don't think it's catching the text to begin with. I'm trying to write a short circuit right now for the OLED print command. It doesn't go and parse all of the text as parameters and stuff. How are you doing, Squid? I want to get the screen working, because then people can put stupid smiley faces on it. And test action OLED print, okay. Oh yeah, I saw you were posted about that jumper IDE. I saw it in the Discord at first, and I was like, wait a minute, this is just Viper, but with more rainbows. But it's cool. I like the customizations that you've done to it. More rainbows is always better. Viper with more rainbows. Or you can make like the like a logo, a rainbow python or something, or rainbow viper. Okay, I think that should work. Let's try this. Okay, yeah, I think I have to connect the OLED. Whoopsie. Oh, well, here we go. Oh shoot, what was it? Dot. I don't know why it doesn't want to stay connected. At least by default, I don't know. You could probably explain it better than me. Alright, let's see. Hey, there we go. Cool. Got a little smiley face. Cool. Obviously, there's some things that I probably need to wrap this code around, or wrap around this code. Let's see. Oh, set that in the commands. Or the config. Okay. Connection, sure. Let's try that. onto file system. Guess I can just edit it here. What is this weird editor? I like Vim. Ah! Give me the file browser. Where is it? Oh, there it is. There we go. Connect on boot, 1, lock connection 1. What's the, what's that font do? Joker Man font. Font 0. Okay, let's see. Oh, gotcha. That's not wide enough. Oh, gotcha, that's cool. You don't actually have to go in and edit the config manually. Is OLED different from top OLED? Hey, what's up, Purple? No, you're not really late. I'm just kind of messing with some of the code for the breadboard. How to reboot. It's like a roguelike that you're not familiar with yet. Where all of the the keyboard keys mean stuff, but you don't have them committed to memory yet. Let's see. Oh, is this that, oh no. What I was messing with earlier was the, you had an overlay that you were showing off in your Discord. Or I guess it was the, so the crossbar status. I have no idea what that did. Oh, it's interactive mode. Oh, let's see if it actually, because I edited the file. I think that should be enough. Yeah, that's fine. Cool. Yeah, okay. Yeah, I wanted to get those overlays hooked into the stream, so they could kind of be like a reference for what's actually connected and what isn't. That way it's easier to see. Oh, nice. Oh, interesting. That's fun. It doesn't have ACM2 anymore. That's okay. There it is. Okay, now it'll work. 18th tries the charm. Okay, cool. Alright, so I was kind of talking about it earlier, but I found on Archive, Internet Archive, this sweet document, 1974 Matsushita Electronic Semiconductors. It's a catalog from Panasonic before they were Panasonic. And it's got a huge list of all their parts. It's a huge document. So anyway, I use this to look up the transistors that are on this board. This is the 1974 version of their parts, and our device is from 1972, so there might be some discrepancies, but I think what I've got here is probably going to get us close enough to get the, or at least be ballpark or something. I don't know. We'll see. But I went and I found the two transistors that I saw on the board. We've got the A749, Just gonna double check. Yes, A749, and then a C828. So here's some relevant specs for those. So when I actually get into putting these into KiCad as new parts, I can actually get the specs relatively close. Shouldn't be necessary to like actually get the schematic made. All I really needed to know is whether or not they were PNP or NPN transistors. So that's fun. Yo, what up, Patrick? How are you? But I think what I want to do is I want to keep going through the board, mapping out some of these pins. And I also wanted to try and figure out which leg on these transistors. I kind of want to test one of the transistors and see if I can figure out more about it with a multimeter, but we can maybe do that later. Does it work? It's probably slow. I've got a really ugly stream delay for some reason. Also, the code might break, so that's a reality too. So I think what I was doing last time when I was tracing the pins underneath the chip, and I think I want to kind of start with the pins on this connector as well. Kind of trace these. Four minutes? That's pretty absurd. Is it really 4? Wowee. It is long. It's not 4 minutes, but that's long. That's like a minute maybe. Sheesh. Potentially. I think it's just my janky setup. I've got my lab setup being streamed to a another box that's doing overlays and stuff. Oh, actually, I don't think I finished tracing out these. How far did I get? S, A, B, C, D, E, F, G. So pin 23. Okay, so we need SP. Oops. I do actually multi-stream on Twitch. At least it should be running on Twitch. I don't really check it a whole lot, to be honest. But it should be multi-streaming. There's no way that works. Overlay set, what is that? Colors 2D. Probably OBS buffering, if anything. Wait a minute, which pin is this? Oh, we're backwards. Alright, rid of this pin. It doesn't go to any of those. Oh, it's that one up at the top. Okay. Would you know if your circuit is faulty or the part is faulty? Well, I'd say burn another. Not necessarily. I mean, if it's an expensive part, I wouldn't. But it doesn't hurt to double check your circuit. And it also doesn't hurt to try it again. It could be just a one-off faulty part, but I don't think that's very common. I don't know. Like if it was a faulty thing, your batch would be bad, right? Let's see, KO, pin 25. Is that, can I do that one up here? Did I mislabel that pin? I think I did. Yeah, that's actually KO. Oh, jeez. Oops. I wonder if that's got something going elsewhere. Which one is that? From The left one, it's actually this one right here. Okay, cool. Oh, where else does this thing go? Yeah, so it looks like it's connected to this circuit right here. Okay. That was this one, this one. All that stuff right there. So wait, KP and KQ are the same? Oh, I haven't even gotten to that side of the board. Wow. Or side of the chip. KP D1, D2, D3, D4, blah, 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 blah. I've got D1, D2, D3. Okay. You can put these in a folder or something. I don't know, Purple. I would probably just throw it out. Unless you want to, like, dismantle it or something. Dissect it. The problem with keeping, like, burnt components or bad parts, that if you don't mark them well enough, and you come across them later, and you try to use them, and you don't remember that they're damaged, that's gonna be, like, massive headaches. So anytime I have, like, a bad cable or something, I just cut the cable. It doesn't actually get used. You can keep the wire for, like, scrap or something, but... Alright, so... yeah, 27. And then 28 is VSS. Did I get that one? I don't think we did. Looks like it goes all the way over to here. Let's test that one real quick. Which one is that? That is, this dude? Oh, other side. Right here. Right before the little squiggly. I'm getting it backwards. I can mirror it to make it better. And then all the way up to here. Nope. Goes off on that. And this right here, this is probably like the common for these transistors on the other side of the board. So somehow this one is going up to not here, but here. And then all of these are the same. I think that one as well. Yep. This one also looks like it. Yeah, I think this is probably just the common, the positive or negative. What's that one on the other side? That one too. Okay. So that one and that one right there, but not these. So I wonder if I can test. Is it yeah, these rails, it's not directly, oh yeah, so that's going to VSS up there at the top. Yeah, see there's this whole rail going underneath all these transistors. Yeah, and this is going all the way up to here. Is that the same? Oh yeah, it is like on the back side of the board. Yeah, that's bridged through the back side of the board right there. Kind of interesting. Let's see. So that is our VSS. Very spicy signal. Is that what that stands for? That's fun. That's going where here? So theoretically, right, that's on the same side, this one, right? Huh. Oh, it does hop through a resistor, so maybe not. Yeah, I'm not sure where that goes. Is that this trace over here? No. Oh! Okay, so that's this pin. Which is third from the right. So this guy right here? That's weird. So this connection goes all the way over here and then comes up right here. Right? Yeah. That's what I just probed. Correct. Well, that's fun. Okay, so that is our pin 28. Is that also connected to that? Oh, looks like it is. Yep. Which means that is connected to it as well. Which means that this is, right? If I probe from here, where is that supposed to be? Middle leg is something, right? Yeah, I think that's the middle leg of this first transistor right here. So this guy. We'll probe it from the back, that's probably a bit easier. Probe, 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 probe. You know what they say, always be probing. Right, that's what the kids say. This way. I got my shit all twisted. So this one goes to that one, blah, blah, blah. Yep, okay. That's that one. Got it. Oh, well, you know, that makes sense. This is that same rail. Comes up through here. So this is all part of the same circuit, I guess. Not sure what those are doing, but those are the C828 transistors. Those were these guys right here. CA28, they're amplification transistors, NPN. So, any big brain circuit wizards out there want to tell me what this is for, go for it, but I have yet to determine that. We'll do that later, once I get all this into KiCad. Okie dokie. Let's see, what else do we have? We just got done with VSS 28. We need to come back over here to our clock pin. I think I got the clock pin. Okay, so I did get clock pin. Let me rename that. CK_1. Might actually be better if I had these named the other way, whereas pin number first, and then canonical name. Boy, they're a mess. 26, 27, 28, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Where's that one? 13. This one I don't think I actually did anything with, did I? Okay, so that one. So I can see it's connected to there and there. What's on the back side? We got this and that. And what about on the other side of those? Oh, look at that, we got a pin. It goes to resistor. Right? Yeah. Cool, and then we start feeding this whole network of transistors over there. And I don't know if this is like an idea or not. But at least we know, like, hey, this is all related to this pin, whatever that one is. What was it? D11. This guy. Digit driver 11. My guess is that all these digit driver pins come out of this whole section right here. Yeah, where does that go? Interesting. And 13. Okay. And then it goes through that resistor over to here. And then from there, I think it goes somewhere under the board. Oh yeah, I think it goes back to that resistor? Yeah, I think it comes back over to here. From here to here again. Let's see. Yeah, so that resistor's on this right here. And then, who was it? This guy? Where are you at? This one. No, I guess not. Huh. This is H. And then H doesn't go anywhere. It might go under that connector, but that remains to be seen. One, two, three, four, five, six, seven, eight, nine, 10, all the way up to 13. And then we need 14, which is our VDD. I think we got that one right. VDD. Okay, so this is one half of the board right there. And here's the other half. Here's VGG, where's that? And is that on? That's pin 15, okay. Oops. Alright, and then that should be the other half of the board. Or chip, sorry, not board. We got 15 through 28. Then our VSS pin, okay. Then you got 1 through, is that 14? 1 through 14, cool. Let's check these out. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13, 14. Alright, cool. So I think we got most of it. Or at least all the pins from the chip. I've got these all splatted out. So now I can just kind of follow through each of these and trace them down to their inevitability. So I guess the question is, which one do we want to start with? Probably not a bad idea to start with like your power rails, like VGG or something. Not sure where else that goes. Oh. This other one right here. Yeah, that runs into our, what is it, VSS? Oop. No, not VSS. VDD? This one, D11. Yeah, so those are kind of the same. I'm not too sure how I want to deal with that problem. Probably just follow it as VGG. Anyway, my husband just got home, so I'm gonna take a quick break. Grab a snack, get some more water. So let's see. I'll give you guys the breadboard view. Does it work? I don't know. Is the code still working? Yeah, it should still be working. So if you guys want to mess with that, you check out the description. You can mess with the breadboard while I'm AFK. So I'll be right back. Hello? Hello, hello? Okie dokie. I got my water. Alright, let's see. Is it still working or is it broken? Probably broken, right? Oh, broken code. Rip. Wowee. Okay, so what pin do we want to work with first? We decided VGG or I don't know. This goes to this resistor network, which I guess we could feed, or we could trace those out and see what they feed into. I'm gonna guess it's these right here. Okay, so those legs are all hooked up to the resistor network. And then I think, these other legs of the other resistors, yes, are also hooked up, alternating. Like, is this one? Yeah, that one. And that one. Oh, is that another one wire over there? No. G. Yeah. Okay. And that is the A749 transistor. Okay, that's fun. So it seems like the to make it a good color for this. Lyrics, no. Let's see. Yeah, so it looks like these resistor networks. Let me get. this color. That one goes to... I had that top one. It goes to the back one. Okay. Is this the clock circuit? Where that clock pin was going? No, clock circuit's over there. What was that other chip, the A749 one? Because this was the amplification one. The other one, I think, was switching. Did I not have it in here? Oh yeah, that's right. It was a different A749. That's a switching transistor. That's the PNP one. And the other one is the NPN. And then that's the footprint of that. Pin 3 is that's the base. What do I want to name this? Let's see, base pins? I don't know. Sure. Then, other pin, that is the emitter, right? Yes. Then we got the collector in the middle. I believe this is probably duplicating the same effort on backside of this one. Oh, I see, it's this first section. So it would be this one coming over to here, right? Oh, there's a bunch of shmoo, i.e. flux, on the board. Okay, so that's coming over to here. And the second one's probably coming to here. Yep, back to here. Okay. Yeah, so that's repeating kind of the same pattern. I don't know where this middle pin goes, though. That's the output or input pin. Oops. Oh well. Did I get that right? B? This one? And I'm thinking it goes to the one right underneath the little thingy thing. No. Does it go here? That one. Which means that A goes to... Right? So wait, that goes to D. It's the one that's in the middle. Okay, I got that messed up somehow. Oh, because I marked the middle pin, right? I mean, I guess you could easily see where it's going, right? Boop. Boop. Right there. I don't know what the hell that is. What is that? Oh, that's going under the under the resistor network. The bottom pin on the resistor network definitely goes to the emitter on this one right here. Here? Yeah, right here. It goes to it. Blah. Okie dokie. And then this goes out to somewhere else. Alright, where does this sucker go? So my photo does not show very well. There's actually a trace right here. Kind of like runs down this way. Does like this thing, and then comes down here and goes to this guy right there. Links to that and that. Those are bridged. That's kind of fun. And then I guess that's the emitter of, ooh, the emitter of a different resistor. Is that still the same kind of, yeah, that's an A749. Okie dokie. And these are all the same A749. I guess I can try to map some of that out in KiCad. Maybe. I don't even know if these are going to be the right, this is like the right pin arrangement or pin layout. I'm just basing it off of this QMSO 100 page. So the pin configuration could be different. Because ours is a TMS 0115. Is it this? No, you mirror vertically. Edit, image, mirror. Vertically? And then horizontally. TMS 0115NC. Ooh. I wonder if I can. Is that? Is it TMS 0115? I got the sucker in front of me. 0115 NC triangle. Nothing. Is it Payland? Bruh. RIP. I don't know. This is good enough data sheet. Or no. So what the hell? Oh, how many is it? 8. Let's just stick this sucker over here. Resistor network 1. Do another. Resistor network 2. Does that work? I don't know, I can move it around. And the 749s are what, NPNs? How many of those suckers we got? Go back to our image. One, 2, 3, 4, 5, 6, 7, 8. And then these are connected, or this one's connected behind this resistor over here. I don't know what the hell that's all about. Is there a way to like automatically align these to align? I don't know. Oop. All right, there's our 8 resistors or transistors. And what is this? That is our base. Oh, I didn't even look where the freaking base goes. Where does the base go? Hmm. Oh, no, wait. Is that the base? No. I'm sorry, the collector. Collector's the middle pin. A. Whoop, whoop, whoop. I got the sheet. Okay. Yeah, collector's the middle pin. I don't have that one. So we can EGG. Sure. What color do we want? Purple. Purple ones. Hey, what's up, Sam? Base pin is right here. These are all the base pins. I may have to track these separately, or they may be all bust as well. Where the hell does that go? Is that a whole nother resistor network? Yeah, that's a whole nother resistor network. Okay. And this goes over here. Yeah, so same pattern, they kind of alternate. Doop, 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 doop. Oh, that's more of a skirt. Skirt. Okay. Doop, doop. Alright, got those. Oh, did I do that on the wrong one? No! Alright. Every Tim. There we go. This is, oops. Nope, nope, nope. This is what we'll do. I'll just subtract a selection because I don't, oops. Bruh. You're not gonna let me do this, Linux. No. Wow. Alright, subtract. There we go. I'll just do it that way. There we go. Subtract those. Subtract those. Okay. Control X. And then go splat these over here. Okay. Wait, no. Something there. Paste into active layer. There we go. Now we've got our emitters. And it goes. I'm trying to reverse engineer a calculator. I've got a, here, I'll show you real quick. And get the rest of the parts. It doesn't really look like a calculator now, but boy, when I show you the rest of these parts, you're like, yeah, that's a calculator. Where is the most important piece? So, oh, it's already in here. Duh. So this is what it is. Let me put it back together. It's a vintage calculator from 1972 called the Panasonic JE850. Well, I guess just Panasonic 850. But it's got some vacuum fluorescent displays up at the top, which is initially why I was interested in it. I got it pretty cheap because it wasn't working, and it currently still doesn't work. But when I saw it, I was like, okay, I need to get this thing working instead of just harvest the VFDs from it. So it's got a cool display. It's got read switch activated buttons on like magnetic rails, which is pretty cool. So theoretically they shouldn't wear out. Yeah, it's pretty neat. So kind of just taking it apart and dissecting the circuit so that I can troubleshoot it. So at the moment I've got, oh, this thing hasn't updated, I guess. Good job, El Gato. It's acting a fool. Let's see if that wakes it up. No. Rip. At the moment, I'm ruining my OBS capture. At least it updated. That's kind of nice. But your resolution is wrong. There we go. Sheesh. Okay. My goodness. Gonna explode everything. Yeah, so at the moment I've got the board, a photo of the board, both sides of it in Krita, is an image editor, and I'm just following traces around on the board and marking them down, and then I'm taking that and I'm bringing it into KiCad and making a schematic of it, so at least then I can kind of, I don't know, figure out what it does and then how to troubleshoot that. Because honestly, I have no idea what's wrong with it. The VFDs are, they're getting like 6 volts. And the VFDs are the little tube thingies. These guys. So they're only getting 6 volts, and according to my research, they're supposed to run at somewhere like 24 volts. And they're not getting 24 volts. They're not getting anywhere near that. So I suspect that this little cube mystery box, is to blame. I think that's a transformer that's supposed to step the voltage up, but I have no idea. Honestly, I'm mostly a noob at electronics, or at least electrical engineering. More of a software person. I do the Linux. Yeah, most of my experience with like hardware reverse engineering is it's more of a software or higher level, kind of dump some firmware and look at that stuff, or like get access to a file system and dig around and mess around with a Linux system. So it's been fun trying to like analyze this stuff on a lower level, on a circuit basis. Ooh, I wonder if that broke my code. Nope. I guess that font just can't render. The font that's on the jumper list can't render that that emoji. That's a bummer, because that's really cute. Rip. I say the hardest part I've found so far about like reverse engineering hardware is trying to find data sheets, and also I don't really know a whole lot about electronics in general on like the hardware level. You know, how people set up circuits and stuff, what the common practices are. Hardware stuff I've been doing for a couple years now. But I've been doing software, computer stuff for basically all my life. guess what, 20 years? 20 plus years? The jumperless guy that was in here earlier, he said that you can change the font. What do you say you could change it to? Oh, that set font Joker Man? Is that even a command? I don't even know if that's a command. Wonder if it is going to... Wow, that did not paste the way I wanted it to. DB was dropped. Hopefully not your database. I don't think it liked that. Hello, Minicom. Did it break you? Rip. Oh, that's right. Okay. What is the baud rate? It's not that, whatever. What do you say the command was? Oh, well, we can see. We'll check the log and see what it's doing. Let's see why it dropped. Why it didn't drop the database. Well, let's set font to Joker Man. Okay. It just broke again. Okay. Yeah, I don't think it really likes that. Oh, you know, it's probably because I have this running at the same time. I don't know. I don't know why it didn't drop the database. It is kind of locked up though. I think I may have killed the device by trying to use the serial at the same time across two different apps. Let me actually do this really quick. MicroPython REPL, blah blah blah. Yeah, I don't know if that actually, is it quit? Exit? I don't know, there we go. Don't know if that actually changed the font or not, but I'm curious to know if the emoji works now. No. Okay. Yeah, I guess I need to find a font for it that'll actually show the those characters. Dag. You guys can also connect wires up. Here, I can give you guys the official view. So you can use the connect command. Oops. Oops, if I have the keyboard on the right one. What is it? Pin 3? Did that not do it, or did that break? Hello, code? Are you broken? What are you doing? Rip. Wonder if the REPL doesn't like it. The MicroPython REPL. This seems to have been quite borked. The Unicode. Rip. Alright, one more try. Now it should actually go. There we go. Is that lit up though? Yes. Cool. Oh no, it's out of focus. Oh! Worst camera. No! There we go. Okay. Okay, so we got that connected. Now let's do pin 4 to top rail. Let's do top. These top bar works. Oh, I guess it doesn't. Well, so much for a demonstration, right? There we go. Okay. Yeah, so there's LEDs. This little circuit right here is a 555 timer. It should have all the components necessary, with the exception of a capacitor. I forgot to put that on there. But there's also some more advanced commands that you can run. If you go check out like the jumper list documentation, basically all those commands can be ran, with the exception of a few. So got this right here to read the docs. So basically all these commands can be used. You can test them. I've got an access control list that I set up that kind of like restricts a couple of them and some of the different things. But if it's not working, I can look at it. And I got a log going, so, and the code might break on me, but it's definitely fun to mess around with. So I've got all the pins mapped for this section of the board going out to these resistor networks, like this one, that one, and this one. I'm trying to bring that over into KiCad. So let's go with this first section. This will be R1. Let me go ahead and rename this. Okay, so let's stick with the base pins on all of these. They should all be connected to resistor network 1. We've got all of these. Oops. That's, we do bus? No. Don't exactly know what the hell I'm doing with, KiCad, so good luck for anybody who knows what they're doing watching me. So they're actually staggered. So this top one, let's say the one's closest to the resistor network. It's top, close, front, back, front, back, front, back. Okay. It doesn't have the pin arrangement, the split middle one though. I wonder if they have that as a part. Eh. No, it's not a divider. I think that's all we're getting. That's all we're getting unless I change the what you use it. Let's actually go and make my own package. Footprint. Yeah, because normally this is pin. I guess I could do that. Let me do that really quick. I want to do that. Yoink. No. There is somewhere where I did this. There it is. Pin table. I think that works, right? 1, 2, 3, 4, 5. I hate that. Oh, that's in the way, though. Boop, boop, boop. Whatever. Wait, can I, in length? Whatever. That's nitpicking. Alright, so now we can come in here. We can replace, right? I think I can just replace it. Change symbol matching library identifier. No, wait. Yes. Oh, change selected symbols. Of course, it's not going to show me mine. Give me. Change. Hooray! I guess I could have just done the custom. Oop. Oh, the theme isn't updated. Oops. Let's see. Reference designator? No. Where are the symbol properties? Where is that? Symbol checker? No. Update symbol fields? Ooh. I don't know where to change that. That's also just nitpicking. Whatever. I will not nitpick. I mean, I will, but I won't. Oh, let's see if set pixel. I don't know if anybody's tried one of those. Let's see. ACL denied action. Here, let me add it. Whoop. Does that work? Did that do anything? I have no idea if that did anything. It ran, but I don't know if it did anything. Yeah, I'm not sure. There's a lot of commands in there, though, that I haven't really, messed with. Ooh, set text size defaults to 2. Oh, I think that could be a good one. Let me add that one to the, ACO. Oh, God. that was not what I wanted to add. Sheesh. What else is there? OLED clear. I guess we could add that one, but we'll keep an eye on that one. It gets obnoxious. Oh, you have to call OLED show after OLED set pixel. So that's why it doesn't work. I bet if you typed OLED, oh, hold on, it's not gonna work until I update it, but that's probably why. And I can probably make that automatic, I think. If our action is an OLED show, oh, I can't update it though. Yeah, not from in here. I could probably check it from somewhere else. That's not a good spot to do that test. Putting OLED show in there, we'll have to do for now. Cute. Now, if we do this, and then we do OLED show. Oh, you know what? There's a problem with my regex right there. So if we go to CyberChef, oops, helps if I have the keyboard. This is my regex for the command. OLED print doesn't actually validate. It's gonna have something on the inside of that, so we have to put in another character in there. Meta character makes that one what is it, optional? It's a lazy match. So we'll update that. And now I bet if I do OLED show, it'll work. Oh, more problems. Interesting. Okay. Alright. Third time is the charm, right? Boop. Ace heal denied constant. Oh my god. Okay, here, I got you now. Oops. Dude. Do that. Or blank string. Alright, fourth try is the charm, right? Boop. Hey. Okay, cool. Oops. Look, we have a pixel now. Now you can draw on the thing. It doesn't show up until you do OLED show, though. I haven't figured that out yet. Need to make it, Here's what we can do. We can do, if f in set pixel. What the heck? What is it? Yeah, OLED set pixel. Oh, that's interesting. Okay. I think I need to add could just pop it onto the buffer. That's probably the best way to do it. So if F is an OLED set pixel, I'm gonna do it right here though. So when we're handling the buffer, next command, let's see. Oh gosh. I do not remember this code. Did I write this code? I wrote this code? Y'all ever do that? You ever write some code and then come back to it later? It's 1 by 1. Sorry. It'll let you do commas, but that's, yeah, in command parameters. Think of it as like a Python REPL. So you're also not limited to, I mean, I guess you are. It depends on what's in the ACL, but it's like a whole Python command line interface. It's kind of how it ends up. Okay, so where the hell do I put this? Because I'm thinking if I get a command that is, like, say the set pixel command, I think what I want to do is, instead of modifying that command and like appending the next, you know, the show screen command, I think just adding that to the buffer of commands to follow it would be better. Okay, so I guess what we can do is, how do we send this to jumper this REPL raw Python string? That's a function that I wrote. Holy crap, what is this? Bruh. You have like a I don't know if it's just me, but I have like a night hyperfixation writing some code and doing something, like working on a project, and then I zonk out in the morning, sleep for like, I don't know, 10 hours, wake up and then do nothing else with the code, and then completely forget everything about it. Hey, look, you got another pixel. Nice. You got 2 of them. I'm so proud of you guys. Alright, so this is our buffer. Yeah, if next command in is OLED set pixel. Oh my gosh, I cannot type. Then what we want to do is send to jumper this REPL. Bonus command is OLED go. Right? And then we want to Rep it. Raw Python string, send to jumper list REPL. No, I think we don't need to. Okay. Oh, I don't want to do that though. Because this pulls it from the top of the buffer. Or from the, I guess, the front of the buffer. Ooh. Hmm. Oh, that's what I can do. I can just, if there's a bonus command. Okay. You know, this should honestly be in, over here. All right, here we go. If response, return response, we'll do that. I mean, maybe not. Maybe that's bad architecture. Who knows? I'm not getting paid for this shit. This is hobby code. All right, clear that out. So if we get our response, we want to do our bonus command. Wait, hold on. What was that? Oh, it just logs an error. Okay. Wait, what? Yes. All right, if response, if we have a bonus command, then we do our bonus command. If next command is OLED set pixel. Parse to REPL gives me that. It pulls it out. Returns REPL command. Doop-a-doop-doo. Crap, I'm lost. I got lost. Send from parse to REPL. Oh, here it is, parsed. What does it send it back as? Oh. Okay. Okay. I think that might be good. If it doesn't just outright break. Okay, here we go. Wow. It didn't break. Okay, so if we do OLED set pixel, $15 is it XYZ? What is the third parameter for in that? What the heck? Is that a pixel? Let's see what it does. I should just rerun it or error out. It's probably gonna error out, right? Next command, OLED set pixel. Oh. There we go. Hey, there we go. Cool. So now you don't have to call show OLED or OLED show or whatever. It just does it now. Hooray. Do I have, is it synchronized to anything? Do I have this on a Git repo? I cannot remember. Oh. Shoot, what do? We changed a couple things. Also need to update that. Git ignore to ignore. Jeez. Nice. What is that? Good luck getting an inline for loop to work. I don't know how that would ever work. If not, just break my code. You're more than welcome to try. I'm not saying you can't try it, but just know it's likely to break my code. Or just not work at all. I don't know if you can do inline for loops in a REPL. You have to figure that out. If you can do like an inline if you try to do an inline loop or inline for loop in a REPL, I don't know. I would figure that out first. Cuz I don't think it'll let you. But who knows? I could be completely wrong. If you come in and inject my code, I will give you I'll give you $5. I'll Venmo you $5. Alright, I'm just adding a commit to Git. Git commit message. What did I do? Shoot, that's the thing I hate about coding and using Git is I can never remember the changes that I make after writing some crap. expanded regex pattern. Is it? Whatever. Author identity. Oh, jeez. What the hell does this want? It's my... Oh. User.name. Do we ever truly know or understand Git? Sheesh. Okay. At least now it's in a Git state or whatever. I don't know. I have to go to the bathroom. So good luck with the breadboard, y'all. Be right back in just a couple minutes. Okie dokie, I'm back. My needy cat wants attention. Meow. Yeah. Alright, I'll give you a close-up to needy cat. No? Oh no, you don't want to talk? Yeah. Yeah, now she doesn't want to talk. Okay. Whatever. Classic cat behavior. Oh, what the hell is that? I wonder what that did to my code. Did that break it? Nope. I don't think you're hitting the regex. You're gonna have to get past this regex first. This doohickey. Yeah, so what this is looking for, and I don't know if you're familiar with regex or not, but I like regex. Regex is a lot of fun. Which is very unusual for people to say, I think. I'm gonna do a video about regex. I'm gonna do like a why you should learn regex video or something. That's like the type of nerdy shit that I think would be fun. But yeah, this regex pattern, it's got a character. This caret means start of the string. Then it looks for an exclamation point. And then this is the first capture group, where it takes any word character. This is a, I don't think that's greedy. I don't think the plus is a greedy match, but basically repeats the character match over and over. What do you want? Yeah. And then it's, then we've got a literal parentheses, so normally those will be like a meta character, but we escape it. That gives us a literal parentheses, so we're capturing this right here. And then this dot represents any character, and we do another match of multiple any characters. Is it greedy? I think it's greedy. Regexer is usually my go-to to mess with it. The cheat sheet's pretty good. Let's see. Where is it? Regex reference. Got quantifiers. There we go. The plus is one or more of the preceding token. It is not greedy. Is it? I don't know. I think the star is greedy. 0 or more of the preceding token. I don't know. Yeah, so then it'll, this inner capture group or second capture group captures everything. The question mark makes it lazy, so it'll stop once it hits a, another one of these dudes. And then the $sign is the end of the string. So that's your first challenge. I like that. I mean, that's a good start here. I want to see what this does. If you take this regex and you go stick it into like, oops, if you go stick it into CyberChef or something. Here, I have it over here. What am I doing? I have it in a log. You can try to bypass the case or like requirements of the regex pattern. This is definitely a side adventure from what I was originally doing. It's fun though. I like poking at things like this. So you're joining that into a string. Oh yeah, that's interesting. Hmm. Yeah, now I'm curious, how would you actually get around that? Or at least how would you make it do, because you're trying to make like a line, right? Trying to do a range. Trying to spit out a range of pixels. So like a whole row of them. Interesting. Because I think technically, let's try this. So if we start this, we can highlight our, let's see, this matches, Because realistically, you only get one set of parentheses. I could open up the regex so that it is way more inclusive and you could just do like one-liners. Oh, here, maybe you could do like a lambda. Mm. Because you have to... Oh, ripperoni. I hope you have a good sleep. And you're nice and rested for work. I think really, realistically, all you would need to do is satisfy the outside condition, which is the exclamation point, words, and then your parentheses. And then anything in here is kind of free game. And I think this is like your attack space, like your surface. From there, you could probably do something like, no. Goodbye. Thanks for hanging out. I'll have to consider this. I'm going to think about this later. Probably be half asleep tonight and then wake up and like, oh, this is how you can do it. Alright. Well, always a fun distraction. I think I was setting up these NPN resistors, or transistors. So, let's see what we were doing. I don't know, how do you start numbering pins? If you just have like a resistor network. Which side do you start on? I guess it doesn't really matter. I don't know. Wait, is it that one on the outside? Where was it? Yeah, closest one is up at the top. Is it the base? Base bin? Make sure I'm getting the right one. Yes, base bin. Base bin goes to that. What? What do you want? What? What, kitty cat? Meow. What? You want my attention? That's what you want. Oh my god, you're fat. And then these boys go like this. Oh, that looks awful. It's very hard to read. What do you want up there? Hmm? Ew. Gross. What is the best way to lay these out? No. What do you want? I want food. Give me food, human. Yep. Bruh, that's so gross. Oh well. I'm just gonna connect the wires. We'll whine about it later. Yeah, whatever. I'm nitpicking. Okay, and then the output is the... Did I get all those? Yes. Oops. Over here. Got the emitters. Those all go to the secondary one. Group of 4 that's closest to that first resistor network starts at the top. Like so. Ew. What if I rotate them? Oh, that's disgusting. Hold on. Oh, gosh. May not even be like the most, readable setup. Anyway, like once I get it on a schematic. Who knows? And then what? This one? Oh, here, you know what? Oh my gosh. Does that do it? Does that solve the problem? Doop. 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 Stupid. So stupid. Okay. Got those. Probably even move them in. Like so. Oh no, a fatal flaw in my plan. Let me move these guys up. How does that wager? It's not that much more readable. I wonder if I can just keep this the other direction like this. And then just have these dudes come out and go to wherever they need to go. Like this guy can go to 9. One can go to 8. No, I don't want you to do that. Okay. Doop. Doop, doop. And doop. Is that it? I don't think that's right. No, because it's the emitter on the... I should start from this one. Wait. No. I don't want that. There we go. It'd probably be a lot easier if I just spaced things out a bit more, you know? Like a logical, insane person would do. I mean, sure. It's actually not bad. That's readable. We've got all the bases connected to this one, we've got all the emitters connected to that one. Cool. And then what else? We have the collectors. And the collectors are all connected to a third one. Okay, so we'll take this little pasty boy. And I think our collectors do over here. Go back and look. Okay. I think this one might be better if we put it over here like this. Maybe. Wowee. This is a mess. Not a label. Global label. Net label. I don't know. I don't know what I'm labeling. Oh, I guess I can just rename these. Where is this actually at? This is the VDD? Oh, VGG, that's what it is. Why do I think it's VGG? Alright, so that's our VGG pen. Okay. This will just be VGG. What? Oh, base. Okay, so that's kind of this little section right here. Where they actually spit out those, where we need to go next. And this all comes from this pin, which is our VGG. Kind of a ground plane, I guess. Okay. What time is it? Kind of been streaming for a bit. Alright, yeah. I think this is a good wrap-up stopping point. Kind of got this little circuit mapped out. Right here. This is all gonna come from... I guess we could put it on there right now. Where's the VGG? Goes like this. Boop. Right. Goes to that guy right there. Cool. So that's all of that set up. What all this shit is doing, I have no clue, dude. So that I'll have to figure out later. But that's what it's actually connected, or how it's connected. And yeah. Cool. Alright, so y'all know the drill. If you want to see more, check out the channel. I got some videos. I just posted a video recently about some reverse engineering stuff that I did. Got Doom working on a time clock, which I thought was pretty fun. Fun project. Yeah, if you want, you can hop into the Discord, hang out, share some of your projects, work on some stuff together. And yeah, thanks for hanging out and watching. Bye!